All right, good morning, Bailey. We're going to go to lesson 4 first, and we're going to go back and do lesson 3. Because lesson 4 in your book talks about the whole number system, and I don't know why you wouldn't start with that. So I don't know if I've drawn these pictures for you before. I can't always remember what I do in which place, but we're going to talk about, I'm going to just skip that first introduction there because I'm going to do mine a little bit different. And I'm going to go right to the next paragraph where it says, the set of all rational numbers and all irrational are called real. Okay, and here is where I'm going to start talking to you today, right here. All right. So our numbers actually are put into categories, just like vehicles are put into categories. We have motorized vehicles that have 2 wheels. They're called dirt bikes, motorbikes. Who's got a dirt bike or a motorbike? You have a scooter? She has a scooter. Is it motorized? Like a little, like can you sit on it, that kind? Oh my goodness. Okay, we have dirt bikes, motorbikes, scooters. We have these 2-wheeled things. Then we have 3-wheelers. Anybody have ever seen or ridden on a 3-wheeler? Put your hand up. Oh yes, my dad has one. They're actually, you can't manufacture them. They're not illegal. They just aren't manufactured anymore because they're actually terribly dangerous. You can drive over your own foot. I have. So you can. They just turn so sharp. And yeah, I could tell you all kinds of stories about my dad on his 3-wheeler. The most notorious one is that my dad is 76. This is probably like 3 years ago. So he's probably 73 at the time. So like an elderly man, but he doesn't act like he's elderly. And he's checking fence up on his cut line. There's a whole bunch of bush, but he's got this cut line and he's checking fence. And he's driving his 3-wheeler, and everything my dad does is really fast. Okay, like he just 100 miles an hour. And so my mom, first of all, doesn't even know for sure where he is. He's just gone out working for the day. Okay, so dad's on his 3-wheeler. Well, the grass is really tall and he can't see it. I told you this story. Okay, so he can't see over the grass if he sits on his 3-wheeler. So he stands up on this 3-wheeler. And he's just ripping down this cut line, and the grass is like tall enough, like you're running, how it would be, right? You're in tall grass. Hits a log, didn't see the log, flips him over, knocks him out, breaks the front tire off of his 3-wheeler. Like the whole thing, the handlebars, the whole thing is like, oh. He wakes up and he realizes it's getting dark and he's been knocked out. He doesn't really know how long. He has to go find the tire, the wheel, the whole wheel, the steering wheel, the whole contraption. And somehow, only my dad, he Jimmy rigs it, wires it back on, and drives this thing home. He's 2 or 3 miles from home. My mom doesn't even know where he is, has no idea where to start looking for the man. I'm just like, Dad, stop doing this. We're going to have your thing home because you have this massive head injury. Anyway, 3-wheelers. Okay, sorry. Okay, so we got 2-wheelers, we got 3-wheelers, we have 4-wheelers of all kinds of contraptions, right? We have actual quads, and then you have vehicles that you drove in, and then we have more tires on your vehicle. Okay, numbers are the same. We categorize them into all kinds of ways. Okay, the very first numbers we start with are called natural numbers. It's what you do when you're first learning to count. They're also called accounting numbers. It's what you do naturally. When you learn to count, when you have a little kid, how do you start? What's the first number you learn? 1, 2, 3. Your mother does not stop you and say, oh no, honey, you forgot 0. Say 0. You just don't do that, right? You start with 1. Look, 1. And I always tell the story that Luke had this little book, because you probably did too, this little hard cardboard little books, you have when you're a little kid. And so Luke, he must have been 2, but I would read the little book to him. And this little book had a puppy dog, and then it had 2 little trucks, and then 3 ducks, and then 4 kittens. Those kind of books? Okay, yeah. So, and he would be like, 1, and he'd turn the page. And he'd go, 1, 2, and he'd turn the page. 1, 2, 3. And every time he said the next number, it got higher and higher. 1, 2, 3, 4. And then 1, 2, 3, 4, 5. And I was like, I'm really glad this book is going to stop at 10 because he would be like, screeching. But natural numbers, you learn to count with 1. And you get a little bit older, and all of a sudden we know about whole numbers. Now, whole numbers include all of those natural numbers and 1 more. Only 1 more, and that's 0. And all of a sudden you're getting a little bit older, and your mom says, no, you're not allowed to have that cookie, and she takes it away from you, and you figure out you have nothing. Okay, you start to learn about zero. Okay, so having nothing is the next step. You getting this? Okay, it's trying to help you remember. So you have natural counting numbers, what you do naturally. Then you learn about whole numbers. And then the next thing is, when you're little, you don't know about negative numbers. Do you know that? You don't know. There's a time in your life when you said to your teacher, you can't do this. 5 take away 7 is impossible. Do you remember that? Remember saying you can't do that, Mom? You know why? Because you think that numbers come in objects. So if you have 5 apples, you can't take 7 away, right? Because you're just little and you don't know yet. And then pretty soon you get older and you talk about money and you learn that you can do it. It's called being in debt. Anybody in debt? Lift high. Nobody's in debt. That's good. Don't be in debt. Okay, you don't owe your mother any money or anything. No? Okay, it's a good time. Okay, so you all know that 5 take away 7 means you're in debt $2. In fact, that's how I teach my teachers, just talk about money, right? Like 5, you have 5, you owe 7, now you owe 2. Okay, so integers are all of those whole numbers. The 0 is included, and then you have the -1, -2, -3, but you have no decimals right now. So -1.5 is not in that list, okay? Natural, whole, integers. Then when we want to talk about those decimals and fractions like 2/3 and 3/4, we call those rational numbers. All right? They have, I want you to also notice the symbols for them. You'll need to know those symbols. So N is for natural, that's easy. W is for whole, integers, that's easy. And all of a sudden you get to rationals and things change. And you have a Q for rationals. Rational numbers are anything like that can be written as a fraction. Any terminating decimals, 1.875. Boom, it's rational. Has an end. Okay. That number up there, 3.14159265358 that number called 5, totally irrational. Have you ever been called irrational? You're being so irrational. Yes? Kind of means you're being stupid, crazy, right? You'll be okay, just wait. Just wait. Someday you'll be married and your spouse will say to you, you're being so irrational. Right? You're just not thinking straight, you're not being logical. Okay. So irrational are crazy numbers. They're crazy. They have no end. That goes on forever. Like, talk about nuts, right? Goes on forever. There's no pattern to that number. There's no repetition. It's not 1415, 1415, 1415, 14. If there was a repetition in that number, or 3.14141414, we would call that, okay, it's not nice, but it's rational. Okay? Irrational numbers have no end, and they have no repetition. Make sense? Irrational. So you have rational and you have irrational numbers. Rational numbers are like fractions like 2/3. How about the square root of 49? Is that rational? Yeah. Yes, because the square root of 49 is actually 7. How about the square root of 5? You type in a nice little square root of 5 on your calculator. Do you get anything that looks good? Sophie? Square root of 5, Maya? Do you like the square root of 5? Are you glad you got the square root of 5? No, it's like it's a stupid number. Okay, it's irrational. The square root of 5 has no end and it has no nice repetition. Okay? 1.5, that's rational. Pi is irrational. And by the way, you cannot be in both categories. There are no numbers that are both rational and irrational at the same time. Okay? All right. All of these numbers together, the whole thing is called real. Go ahead, ask me the question. These numbers are called real. What do you want to know? Are there non-real numbers? Of course there are. There are imaginary numbers that we will not talk about in high school. If you go on and get a degree in mathematics, you will talk about those imaginary numbers. They're called complex numbers. I turns out to be the equivalent of the square root of -1, which you can't have. Yeah, so they're imaginary. There are imaginary numbers. Yes, there are. But you don't need to talk about them. You'll just talk about real numbers. Okay? Real numbers, that's like your universe. Okay? I shouldn't call it universe. That's like your galaxy, solar system, right? Yeah. Okay, here we go. So here's the real numbers. They're split into two main ones. Rational which we're going to call Q, and irrational, write this down, which we're going to put a line over it. That means not rational. Now, I did not know why we called Q. Okay, we can't call rationals R because that's for real. And real numbers are R. This. So I can't put real and rational. So Mrs. Lynn said to me, I was brilliant, she's like, I bet you it's for quotient. Q for quotient, because everything that's rational can be written as a fraction. Do it 7, hardcore 7, just a plain old 7 could be written as a fraction. How do you write 7 as a fraction? 701. Boom, fraction. Right? 29 million, put it over 1, you got yourself a fraction. Okay? So all the rational numbers can be written as fractions. You should write that down. Okay? So rational, there it is. It's A over B. But think of that as being fractions. Okay? And fractions include a lot of whole numbers. 36 over 2. Well, that's actually a whole number. It's called 18, right? So Q, no doubt, stands for quotient, which is like fractions. Okay. So we have this real number system that's like the galaxy, like the Milky Way or whatever we live in. And then we split it into 2 parts. Maybe we should just call this the world. I don't know, whatever. Okay, this is your world right now. And we have the irrational over here and the rational over here. There's no more subcategories in the irrational section. Just write like pi square root of 5 in there. Okay, there are no other numbers. There's no subcategories of irrational. They're just the crazy numbers, okay? They're the ones that have gone crazy. Okay, then in our rational section over here, we have a whole bunch. So these are fractions like 2.5, and what? 3/4, let's put that down. Okay, fractions and decimals fit in that rational category. The next subcategory we have of rational, if we're going back up the chart, are integers. So this is the integer section. So integers include -5, -4, and then 1, 2, and 3, just the numbers you think about, and there is a 0 there. In the whole numbers, we don't have those negatives. We just have 0, 1, 2, 3, 4, 5 on to infinity. And then what is the very smallest set of numbers? Natural numbers, right? So we're going to put an N for natural. And the only difference between natural and whole is that natural don't include what? Right. No 0. Oh, I keep doing that. No 0. So just 1, 2, 3. Okay. See how it kind of works? One fits in the other. By the way, all the natural numbers are whole numbers. Everything that's whole is considered an integer, but not the other way around. The integers include more things than the whole. Does that make sense? So we could also talk about, I live in Bergen, which is in Alberta, which is in Canada, which is in North America, and the other people are crazy. No. In the world. Okay, get it? One's inside the other. So Bergen's in Alberta, but not all of Alberta's in Bergen, right? Makes sense. Okay, turn the page. So you have some acronyms, some little things. Let's put them in here. What does it says for each of the following? Write all the sets of numbers to which the given number belongs. All right. So right off the bat, anything on this page that you can see is called real. All right. So we're going to put an R at the bottom. They are all real. That will be the very largest set we can talk about. Okay. So I like to start from the smallest set and work out. So does 9 belong to the very smallest set, which is called natural? Is 9 a natural number? Yes. So put an N there. So then is it a whole number? Yep. Is it an integer? Yes. So we're going to put I there. And is it rational or irrational? Rational. It's a nice number. So we're going to put Q. All right. 11 over 7, is that a natural number? I don't know many kids who can talk about that when they're just tiny. They're learning to count. Not very many. No, it's not natural. Is it whole? No. Is it an integer? Nope. Integers are positive and negative, like -7, -8. No decimals included in integers. 11 over 7 is a decimal, right? So it's not natural, whole, or integer, but it is rational. You put a Q on it because it can be written as a fraction. Okay, square root of 5. Is it natural? No. Is it a whole? No. Is it an integer? No. What is the square root of 5? Do you know what it is? Is it nice? Angelina says no. It's crazy. That's called what? Crazy numbers are called irrational. So put a Q with a line over it that means not rational. Okay, -7. Is it natural? Is that how you learn to count? Nope. Is it whole? No, that only includes 0. That's only one bigger than natural. Is it an integer? Yes, it's an integer. Integers include negatives. And because it's an integer, then it's in that rational set. It's in the side of the world that's rational, and that makes sense. Okay. Then it says, explain why 9 belongs to 5 number sets. Right here, the number 9 belongs to all of those, but -9 would only belong to 3 sets. When I put a negative in front, what sets are eliminated? Natural and whole, right? So because of the negative, it's not natural nor whole. Good. Okay, kind of make sense? Okay, I have a couple more things to show here, and then we'll flip back to the previous one. Square roots. Most of you know about square roots, right? Oh, there it is. I was going to say, make me the list of perfect squares. 1, 4, 9, 16, 25, 36, 49, right? You know those. I've drilled those into you. I hope you remember those. You'll need those. They're very handy. Yeah, we'll talk about them all the way. Do anybody know 15 squared? Come on. 15 squared. 225. 16 squared. Got rusty in old age. 256. Yeah, 17. 289. 18. 324. 19. You know we're in the which hundreds? 300. What does it end with? A 1. So 324 for 18. So 361. 361 for 19 squared. And 20 squared is, let's do it again. 15 squared. 16 squared. 2 to 6. 17 squared. 18 squared. 324. 19 squared. 361. And 20 squared. Okay, so you can make that list a whole lot longer than it is on there. Oh, it's up to 15. Okay. Here's a fun one. What's 12 squared again? 144. Do you know what 21 squared is? Yeah, that's kind of a fun one, right? Flips around. 441. Okay, good. Okay, so square roots. The only thing you need to know really here that you wouldn't have known before is that all positive numbers have 2 square roots actually. One positive number and the other a negative number. The positive square root is called the principal square root and is denoted by the symbol this, the square root symbol. Okay, so in this book, when you see the square root of 9, you only have to write down 3. Okay, although, isn't it true that 3 times 3 is 9? Isn't that true? 3 times 3 is 9. Isn't that why you say the square root of 9 is 3? Well, isn't it also true that -3 times a -3 is also 9? It's positive. So that's why there's these 2 answers actually. But in this book, we're just going to talk about the principal square root, which is just the positive one. Whenever you see that symbol there, okay? So it is true that the square roots of 16 are actually 4 and negative 4. That is a true statement. But when you, in your book, see the square root of 16, you only have to put down 4, okay? You on it? There's a question about this in the book. You'll see it later. By the way, the square roots of a non-perfect square, we're reading here, the square roots of a non-perfect square are called irrational. So that square root of 5 is a non-perfect square, so it's called irrational. And it doesn't have any nice answers. Okay, so sometimes, if you remember, I made a little list for you, and we had to estimate what the square root of 46 was mentally. Remember doing this? I had this big number line and put the square roots above. Do you remember? Okay, it looks like this. Right? Like that. And we put the equivalent of that as square root of 1, square root of 4, square root of 9. Do you remember doing this at all? Someone talk to me.
Yeah.
Okay, 25. This was square root of 36. That's the same as 6, right? Square root of 49 is same as 7, and the square root of 64 is the same as 8, correct? Those are all equivalent. So those are on my number line. So when you see the square root of 46, do you remember how to do this? Come over here and you say, well, the square root of 46 lies in between those two. That means the answer has to lie between 6 and 7, right? And it's a little bit closer to the 7 than it is to 6. So what do you think it's going to be? 6.8? Now, someone type in the square root of 46 and tell me how close we are. 6.78. We nailed it. Perfect. Pretty cool. Okay, 2 root 18 plus 5 root 37. What does this mean? 2 root 18. Do you know what the 2 is doing to the root 18? It's multiplying. So that means 2 times the square root of 18. What's the square root of 18 approximately? Well, 4.1 maybe? 4.2. Times it by 2, 8 point. How about we say it's 8.2? What's the square root of 37? Well, it's basically 6. So I'm just going to say 6 times 5, 30. So I think this is going to be 38.4. You know, you're making it up. You're just kind of estimating. Now, take your calculators, and do you know that you can type in, if you have the TI-84 calculator or 83, you can type in 2 root 18 plus 5 root 37 just in your calculator and hit enter. Do you know that? It works. You don't have to times anything. You can literally type it in like it looks. Now, wait a minute. If you have a fancy calculator, you might have to press the 2 button. So 2 square root 18. Okay. If you have a fancy TI-84, if you type in 2 root 18, it leaves your cursor under the radical sign. So you have to hit the arrow over one, and then it takes it out of the radical. See what I just did? And then you can hit plus 5 root 37. Go ahead. So make sure you have stuff out of the radical. Then do plus 5. Okay, you don't have to do that all in like this. You go 2 root 18. Put it over. Plus 5 root 7. Oh my word. Oh yeah. I said 38.4. Hannah got 38.89. That's pretty close.
I got 13.
Okay, she got 13.
You forgot to
So, okay, so what's important in your calculators is that you need to close the square root part. So on Angelina's, it goes like this. On her calculator, she goes 2, puts in a root, it gives you an open bracket. Then if she puts 18 and then puts plus 5, what is happening? All of this is still under that radical sign. Catching on? So you have to close your bracket. So this is super important. Okay, so you have to, on Angelina's, when it gives you an open bracket, you have to close that bracket manually, like put a parenthesis in there. Close it, and then put plus 5, radical, it will give you an open, and you can put 37. Closing that one when it's the very end isn't as important, it doesn't really matter. but you have to make sure that you close your bracket. So this is a good lesson in how to use your calculator. So everybody do it and make sure you get 38.89. Have you done it? You typed it in so you know how? Nothing as frustrating as being on a test, getting wrong answers because you can't use your calculator. Okay? Isaiah, did you get it to work? Awesome. Logan? Adrian? Okay. All right. That's all we're going to do. Oh, okay, cube roots. Ready? Turn to the next page. Cube roots. Cube roots have a long list of numbers. There are a different list. 1, 4, 9, 16 is not on there. 1, 8, 27, 64, 120, 125. 6 is 216. Is that right? 7 times 7 is 49 times 7. 343. 8. 343. 8. 424? No, what is it? Oh, 512. Okay, so you kind of, memorizing those cubes, if you actually just learn to 5, you're probably good, or maybe to 6, 7. Anyway, those are numbers right in your list. So if you had to find the cube root of 11, the cube root of 11 is going to fit right here, right? Pretty close to 2, so I'm going to say 2.2. But you have a calculator that will do those for you. By the way, are you allowed to put a negative number under a cube root? The answer is yes. The cube root of a negative 27 means 3 numbers times itself that make negative 27. Does negative 3 times negative 3 times negative 3 give you a negative 27? That's the question. Is it true? Yes. So here, ladies and gentlemen, you find out you can put a negative under a radical sign as long as it's a cube root. For fun, can you find me the square root of a negative 16? No. Put your calculators down. What is the square root of a negative 16? Does it exist? What could it be? 4? 4 times 4 is 16, right? But you wouldn't get the negative. Could it be a negative 4? Well, negative 4 times negative 4 is a what? Positive 16. There is no way in your world to get a negative 16. It doesn't work if it's a square root, because that only allows you 2 numbers. This, by the way, is not real. It exists, but it's in the imaginary world. So does it exist? That's a good question. If it only exists imaginarily, does it exist at all? Okay, this is a non-real answer. It's not real, okay? It's not in your real world. But the square root of a cube root of negative 27 does exist because you're allowed to have 3 negatives. Fun fact, okay? All right. Why don't you take a minute and do the questions in this lesson first. So in lesson 4, I'll give you like 15 minutes. And then we'll go back and we'll do lesson 3. Yeah, please. So we're doing lesson 4 right now in your homework, so be careful on your blue sheet that you find the right one.